Audible, right?
Yes, very audible.
So now this is what the output that we expected, right?
Yes, sir.
Yes or no? Let me save and show you the output. Let's save this. And you see what happened. Hello 1 printed, hello 2 printed, and after 4 seconds, hello Arvind got printed. And what we expected, hello 1 will be printed first, and then hello Arvind will be printed, and then hello 2 will be printed. So
Yeah.
let me show you the memory level. So we are getting a different output. We expected a different one, and we are getting a different one, right? So what I'll do is that better I'll take the annotation of this Jones only. That is good. Okay. So what I'll try to do is that I'll write the stack memory. Yes, this is our stack memory. And then you see, firstly, what will happen?
Global execution context.
Global execution context gets created, right? So this is global execution context, and of course set time out is a already built-in function, so that will be ever always there. Okay, and then which one will be created? There are no variables, so
Yes.
nothing to be hoisted and nothing is there. Don't think of this set time out because it is there in build. Okay, actually set time out will also get hoisted with fully hoisted because it is defined in the background. Okay, so I'll write that set timeout will be hoisted fully, and then what will happen? This instruction gets executed. So this is what, this is my console, and what will be printed here? Hello 1 will be printed at line number 4. And then what happens is that since it is a function call, and you see that function variable exists in the global execution context, so what will happen? There will be another execution context for set timeout will be created, right?
Yeah.
Yes or no? And then
Yes.
For 4000 seconds it will last, for 4000 milliseconds it will last this particular block, and then this function will be executed inside that, right? Yes or no?
Yes, sir.
So this function will be executed inside that, and after 4000 seconds what will happen? This will be erased, and then we'll get back to this, and then that means we are done with the 5th instruction, execution of this 5th instruction. Now what will happen? We will jump into this 8th instruction, and then here actually hello Arvind was printed, right? Okay, and after that we will be executing this 8th instruction, which is hello.
What?
To mute yourself. Who is that? Prasanna and both of you mute. Yeah. So you see, this is what we expected, but it is not the thing happening. Are we bad at concepts, or are we learning something in a different way, the concepts? Why it is not working? So here is a big question for us, why we are not getting this. Let me tell you why the things are not expected here. Let me tell you, this set timeout is called as a web API. Okay, it's called as a web API. That means it is a function. API means some code. Okay, don't think in deeper. Okay, what is API? API means some program which can do some function. So this set timeout is a function which will have some code inside that function, and that function we are calling as an API, application programming interface. Okay, so now what we'll do is that this is not the thing happens when you call a web API like this set timeout web API. Actually, whenever you make a call to this set timeout API, that will not be clear, that will not be taking some space on the top of the stack. But instead, what will it do is that, let me erase this, all these things. So this is what we expected, but why it is showing a different behavior? I'll tell you. Just focus more. This is most important. Okay, because in case of asynchronous programming, this is working. Actually, what is the disadvantage of what is the disadvantage if it works like this? Can you tell me, is there any disadvantage? If the way we expected, if the same way the code gets executed, is there any disadvantage? Hello?
Yes, sir.
I'm asking you, after creating this execution context for the set timeout function, we are waiting for how much time? 4000 milliseconds.
Milliseconds.
So this is a big disadvantage, right?
Yes, sir. It is a disadvantage. It has to wait for.
Because for executing only this particular instruction, if we are waiting for 4 seconds, then let us say our code is of 10,000 instructions need to be executed. So the program will become very lazy to execute all the 10,000 instructions, right? So that's make a big disadvantage. That's why it is not implemented as like this. It is the set timeout function will be implemented in a different manner. Okay, I'll tell you how does that implemented. Okay, so that's the disadvantage, and to overcome that, the developers designed the set timeout API in a different way. And what is that different way? We'll see now. Okay, till this point, is it clear what I'm trying to say? Hello.
Once again, repeat, sir. Disadvantage.
See what regularly needs to happen is that, so first day after executing this console log of the first instruction, what will happen? Hello one will be printed, right? Let us work on our regular way. Okay, so hello one will be printed on the line number 4, right? And then immediately in the 5th line it is a function call, and the function is present in the global execution context. So what will happen? The function local execution context will be created, which is set timeout, right? Okay, so set timeout execution context got created here, and in which we will have to wait for 4,000 milliseconds to execute this particular function within this only, right? And after 4,000 milliseconds, what will happen? Hello Arvind will be printed.
Yes, sir.
Right? So this is at t equal to 0, and this is at t equal to 4 seconds. Okay, this is at t equal to 4 seconds. And after 4 seconds, what will happen? The control goes to line number 8 and it will be printed. So hello 2 will be printed. Right?
Yes, sir.
Yes or no?
Yes, sir.
So, but if you look at the output, firstly, the hello 1 printed. So, okay, fine. And secondly, hello 2 printed and not hello Arvind. And that was printed without any time. You see, let me save this. And you see, hello 1 and 2 are printed immediately. And it is only waiting for this hello 3 gets printed. Hello Arvind gets printed.
Yes, sir.
You see, hello Arvind got printed. Let me resave, and you see, hello 1 and 2 got immediately printed. That means this one, after executing this one, immediately this is got executed, and this is not got executed. But after 4 seconds only, it is got executed. Right?
Right.
I'll tell you what is the things behind this. Okay, why it is happening. So let us see. See, I'll make this one. Okay, firstly, how can I start this? Okay, so I'll draw the structure of this. So what is this?
CPU.
What is this? No, it is called stack.
Okay.
So it is called stack. Okay, and there is something called web APIs, which are the functionalities that are there inside the browser. Web APIs. So in web APIs, console object is a web API. Okay, and set timeout function is a web API. There are so many are there. Set timeout is a web API, and fetch is also a web API, and so many are there. Okay, now we are interested to know about this set timeout, right? And how does that implemented? Okay, now here is something called event loop. I'll tell you what is this event loop. So these are the not hardwares, but these are the programs. Everything is a software. Only this call stack is a hardware. It is RAM, right? It is a part of RAM, and this web APIs are software only. That means some code is there in each of them. Okay, and this event loop also has some code. Okay, it is also a software. And then there is one thing called callback queue. What is this? Callback queue.
Callback.
So I'll tell you why I'm writing all this. So firstly, what will happen for this particular program? Global execution context gets created. Okay, and within this global execution context, there is a function called set timeout, which is hoisted because it is by default there. Always it will be hoisted. Always means even if you are not using this function, that will get hoisted because it is a global function. We can access that. Okay. Now what will happen after that? We'll get into execution phase. So on the console, the first line will be printed. After executing the first line, hello one will be printed. Now, whenever you make a set timeout call, what will happen is that whatever the first argument is there in that, which is a function, and that function I'm naming it as func, let us say, as of now. Okay, This function is I am naming as func. Okay. Now this func will be registered somewhere. Just think it is registered somewhere, and the timer starts on this. Okay. The timer starts on this. So this is what timer starts on this at t equal to 0 till where t equal to 4 seconds, because I made it to a 4 seconds or 4000 milliseconds. So what will happen now? This got executed, right? Now what will happen? The fifth instruction, whenever the fifth instruction gets executed, what will happen? That function, whatever the first function is registered, that the first function is we are passing to the set timeout function, that will be registered outside, and then there will be a timer starts for about how much time? 4000 milliseconds. Okay, is it clear? And then what will happen immediately? Console log hello2 will be printed. So on the console, which one will be printed? Hello2 will be printed when it executes for this line number 8. Okay, and after executing this one, what will happen? The global execution context gets erased because all the instructions are done, right? Yes or no?
Yes, sir.
Let me remove all this, and all the instructions are done executing. So the global execution context got created. Now this stack is what? Empty. Okay, the stack is now what? Empty it is. Okay, so when the stack is empty, whenever a function pushes into this, or whenever a context pushes into it, what is the work of stack? Stack will, execute that function or the context, and it will remove after execution, right? So that's what the stack does.
Yes, sir.
Yes or no? So since we are executing this, after the timer gets completed, what will happen? This function context will be spawned within this. What is this?
Function context.
Function context. And what are there within this function? Only a simple console log statement is there.
Yes, sir.
And that will be printed here. Is this clear?
Yes, sir.
If not, I'll make a complex one now. Okay. I'll take a complex example because I need to discuss about all, and it will take a lot of time. Okay, don't worry. So I'll be removing this. First, I'll create a function called test1. I'll also need some variables. Okay. Let a is equal to some country. Age is equal to 22, and then the log in both of them. Log. That's it. It is a function, right? Now what I'm trying to do is that I'll be, making a set. I'll be using another function. Okay. Test2. And let x is equal to 200, and then let y is equal to 300, and I'll be logging sum of x plus 12. So I'm just creating functions just for using only. So I'm calling the set timeout function. So for the first set timeout, what I'm doing, I'm going to call the function just test1. I'm making a callback for the test1 function, and then I am setting a timer for this, which is 3000 milliseconds. And again, I'm going to call the set timeout function for the second function. Okay. And again, for this, what I'm going to do is that I'm going to give the same timing. Okay. And here I'm going to make a console log hello1. Okay. And here I'm going to make a console log hello, do something like this. Okay. Now here I'm going to make a log of hello3. Okay. Now what I'll do is that
Create a call stack first.
firstly I'll capture this. Okay. Here, and I'd like to write it everything here on. So just try to observe carefully. What I'll do is I'll create some boxes. Actually, I'm not able to create any boxes here. What is this?
Call
This is
stack.
call stack. Okay. And what is this?
Queue.
It is callback queue. Okay. And what is this?
Callback.
Something.
Something.
Yeah, let me name. I'll name all of them. Okay, don't worry. So what is this?
Call stack.
This is call stack. Okay, and what is this? Web
Del-
APIs. And this is callback queue.
Callback queue.
And here is the one which is what I'm making as an event loop. Okay, all things will be covered within this only. And I'm naming some of the web APIs. There are actually bunch of web APIs out there, around hundreds of web APIs out there, but out of all of them, we are going to use only 2 to 3. Okay, and I'll write all of those 2 to 3. So till now, what we used, which is console, right? So console.log, console.time, console.time end. So that means console is a big object wherein a lot of functionalities are there in that. Like log is a function, and time is a function, time end is a function, table is a function. Yesterday someone shared in the Instagram page link, right? So console is a big object which has a lot of functionalities. So console is a web API, remember. And then another web API is set timeout function. And do you know the functionality of set timeout function? It will basically take 2 parameters. First one is a function, and the second one is a number. The first function will be executed after those many number of milliseconds in the second parameter.
Yes, sir.
Okay, that means in this case, if you are passing test1 function, after 3000 milliseconds, the test1 will be executed. Okay. Now there is another API called fetch API. Fetch, and there is another API called XML HTTP request. So what are all these? These all are some JavaScript objects or some kind of, JavaScript functions. So this is a function, right? And this is a big object because all we are accessing by using console dot something. Console dot something means console is a big object. Fetch is also a function. Okay. And XML HTTP request is also an object. You don't know as of now all of these three. All of this we have used only console, and we have used only the set timeout, and you don't know these two are actually useful for fetching some data from some remote servers. Okay, so we'll see this when time comes after discussing down. Okay, now these are 4 web APIs that I'm writing here. Now what I'll try to do is that, so firstly, what will happen in the call stack? Global execution context gets created when I run this program, right?
Yes.
And after creation, what will happen? There will be hoisting takes place. So which is test1, which is assigned to something. Okay. And test2, which is assigned to function, and set timeout is also assigned to something.
Yes.
Because it is by inbuilt. Okay. Now these 3 are the functionalities that are there inside this global execution context. Now what will happen? We'll jump into execution context. So in the execution context, so let us say this is our console. I'll write the console here. Okay, and this is my console. I'll write it here. This is console. And what will be printed after execution of first instruction? Of course, hello one will be printed, no doubt within this. At line number 4. Okay. Now what will happen? Since from line number 5 to line number 9, it is a function description or definition. So we are going to skip this. And at line number 10, what will happen?
Hello 2 will be printed.
Yeah. What about remaining people? Why are you not responding? Shiva, Prasanna, Sai. Okay. And from line number 11 to line number 15, what is this?
That will be skipped because that is function.
Skipped because that is a definition and it is already been hoisted, right? And what is this line number 16?
That is function called set timeout.
Yeah, it is a function call for set timeout. So whenever we make a function call, what should happen? There should be a context created on the top of the call stack. Yes. But it is the case in regular functions and not in case of set timeout function. Remember that. So whenever you call a set timeout function, what will happen is that whatever the function you are passing, that will be registered somewhere, like test1 is registered for about 3 seconds. Okay, and the timer gets started for this. Okay, so timer gets started for this, and after 3000 seconds only we will have to handle this particular function. So it is not like set timeout context will be created on the top and we will wait for 3000 seconds. No. Okay, so since we are making a set timeout function call, it is like, you know, the function test1, whichever we are passing as a first argument for this, will be registered, and after 3000 seconds only it will be called back. I'll tell you how it will be called. Okay, and then after executing 16th line, then immediately what will happen, we'll jump into
17th
line
line.
number 17, and it is also a set timeout function. So what will happen,
Again, sir,
test2 will also be registered somewhere means in the memory only, but in the heap memory. Okay, and then test2 will be registered for about how much time,
3 seconds.
3 seconds again. So the timer of this one will start now. Okay, after 3 seconds completion only we have to handle that. So then again, now it is once registration only, this is the process of registration. This execution means it is the process of registering those functions for about that time. Once we register, that means we are done with that instruction. Okay, and then what will happen, we'll jump into line number 18, and in line number 18, what is there, hello 3 needs to be printed. At which line? Line number 18.
18, sir.
Right, and after line number 18, is there anything? Nothing is there. That means which one needs to be removed from the call stack? Which one needs to be removed?
The
global execution context.
Test2 will be removed and set.
No, the global execution context entirely gets removed,
yes,
from
sir.
the call stack, right?
Yes, sir.
So now the global execution context got removed. Okay, now what will happen is that, sorry, now what will happen is that after 3 milliseconds, that means let us say now after some time this timer got completed. By the way, out of these two, whose timer will get completed first? Who registered first? This one, right? And who registered next? This one. So after registering this, how much time it will take to register the second one? Because those two instructions are side by side, so they will take around 0.00001 second, 1 milliseconds, right?
Yes, sir.
Very small amount of time only. So that means this is the one which is registered earlier. So it is the one need to be pushed. This timer will be completed first,
yes,
right? So after this timer gets completed, what will happen is that this test1 will be pushed inside of call stack. Sorry, callback queue. Okay, so this one is pushed into the callback queue. You understand?
Yes, I understand.
Right, so after it is pushed, and this event loop is the one responsible. This looks on both of these two, like callback queue and call stack. So whenever the call stack is empty, what will it do is that if there is something in the callback queue, whatever is there in the first place, so that will be given into this call stack. So now the test1 execution context gets created here. Okay, and during this process of time, this timer will also gets completed, right? Because all of these are, they registered immediately one after the other. Okay,
yes,
once it is then when it is been pulled and pushed into this call stack, what will happen? It will be removed from the callback queue, right? So it will be removed from the callback queue, and after removing, what will happen? Before or after removing, immediately what happens?
Test2 will be supposed in callback queue.
Yeah, test2 will be pushed into callback queue. Now test2 is here, and event loop is the one it is checking. Now test1 is actually executing, right? That means the call stack is not empty. Okay, and event loop pushes the one which is at the top in the callback queue into the call stack when the call stack is empty. But as of now, test1 is not empty, right? So call stack is something, some context is executing in the call stack. So it is not like it is going to push that function into here. So whenever the call stack becomes empty, then only this test2 will be pushed into it. Got it?
Got it, sir.
Right. So what is the execution? Now the execution context of this test1 got created. So firstly, what will happen? Creation phase. Creation phase, nothing will happen, no hoisting, and only A will be there, which is 20, and age will be there,
22,
which is 22, and then console log of A and age.
Yes, sir.
So 20 and 22 will be printed at which line?
The line numbers are 8, sir. 8.
And then once it reads this line number 9, what will happen?
Sir,
the
that
context
will be
gets
removed from call stack, sir.
Yes, this will be removed from call stack, right? And I'm removing this arrow as well.
And immediately after removed, event loop will
The call stack, yeah. Now the call stack got empty, right?
yes.
So since the call stack got empty, what does the event loop do? Event loop will push the whatever the one is there into this one. So test 2, sorry, it is. So once it is pushed, then it will be erased from the callback queue. Okay. Now what happens? Test 2 context got created and test 2 will be executed, right? And what is there in text 2? Test 2
X and
x
Y.
is there, which is 200, y is there 300, and console log of x and y. That means 500 will be printed at which line?
14.
Line number 14. Okay. Now after this, what will happen?
So that will be removed.
This
and
will also be,
that will be empty, and simultaneously callback queue will be empty.
so simultaneously callback queue is also empty. And does event loop do anything? Because there is nothing in the callback queue, so it does not do anything.
Yes, sir.
Okay. Did you understand this process?
Yes, sir. Understood.
Now what is the output? Hello 1 is the first, hello 2 is the second, and hello 3. Now, yeah, hello 3 is the third, and then 2022 is the fourth, and then 14 is the fifth. Did you understand this?
Yes, sir.
So let me save this, and you see hello 1, hello 2, hello 3. That means till here it has been done immediately, and after that those who registered first, that is got executed. So that's why we are able to print this A and H, and those who registered immediately next with the same time, that is got executed with immediately, which is summation of 200 and 300.
For line number 16, just gives us 4,000, sir.
Okay, when I give 4,000, could you expect what will happen?
I think, sir, line number 17 output will be come first, and then, sir, 16.
Yes, exactly, because you see, let me show you this.
But, sir,
no, you see, so this one is having how much time? That's a good idea to make that. So this one will be, the timers are different, but they both are immediately registered. So this one is having a time of 4 seconds, and this one is having a time of 3 seconds.
3 seconds.
Right? And who will get completed first?
Test 2 will complete it first, sir.
Yeah, so test 2 will be pulled into this callback queue, and it will be pushed into it, and that will get executed, and it will be removed. And then this will also be removed since it has been pushed into call stack. And then this test 1 will be, after 1 second, test 1 will be pushed into callback queue, and then it will be pushed into call stack, and then that will get executed. You see, now the output will be something like hello 1 first and hello 2 next, right? And here are the 2 registrations done. 2 registrations are done in line number 16 and 17, and then here in line number 18 will be executed. So hello 1, hello 2, hello 3 will be printed in sequentially without any time delay. And after 3000 milliseconds, what will happen? Test 2 will get executed. That means inside test 2, 500 will be printed. And then after 1 more second, what will happen? That means whenever it is trying to complete those 3000 seconds, within that also it is also going to complete those 3000 seconds, right?
Yes, sir.
So after executing this, immediately after about 900 milliseconds or 1 second almost, what will it do? This test 1 will get executed. Let me save, and you see 3 got executed immediately, and then 500 will be printed here, and then 20 and 22 will be printed after 1 second. So there is a time gap of 1 second between these two, if you guess. So let me make it to 6000, and you see, firstly these 3 things will be printed fatafat without any gap, and then after 3000 milliseconds, this test 2 will be executed. That means 500 will be printed, and after that about 2.9 milliseconds or 3 seconds almost, this test 1 will get executed, and that will print age and A and age. Let me save. 3 things printed fatafat. After 3000 ms, 500 printed. After more 3000 ms, this got printed. You got this? So there is so many messages.
Sir, got it, sir. Sir, if someone will ask me what is a webAPI, then what will I tell?
What?
Someone will ask me what is webAPI, what is its usage, something like that.
See, set timeout is a simple web API, which is to execute a particular function after the time whatever we required.
No, sir, actually,
okay,
simply
something like
web API.
Yeah, simply web API means there are some additional functionalities provided on the browser JavaScript, which help us to do something. Like if you wanted to fetch some data from some remote server, you have to use a web API called fetch API. And if you want to handle the, actually I forgot to read one good example of this. 1 second. there is a web API called DOM. Okay. I did not discuss this. Actually, we are going to see this web API tomorrow. So DOM is the web API which we are going to do. Check this tomorrow. DOM is also what? Web API. So here it is, what kind of it is? It is an object like XML, HTTP request and console. So document is a big web API using which we can handle the entire HTML document. Okay.
Okay.
How to change the order? Which order, Prasanna? Unmute and talk.
సార్ వినిపిస్తుంది సార్. హెడ్ ఫోన్స్ మైక్ పోయింది సార్. నేను తీయాలంటే ఇది ఇయర్ ఫోన్స్ తీయాల్సి వస్తుంది, క్లారిటీ ఏమో సరిగా లేదు, అందుకే మాట్లాడలేదు సార్. అంటే ఇప్పుడు మనకి ఫస్ట్ 16 సార్, యాక్చువల్లీ ఫస్ట్ 17th లైన్ రిఫ్లెక్ట్ అవుతుంది కదా సార్.
అవునవును,
అది ఓకే సార్. బట్ కాకపోతే 16th లైన్ ముందు ఉంది కదా, దాన్ని క్రాస్ చేసుకొని ఇది పైకి ఎట్లా వెళ్తుంది
అంటే ఒకటే కదా. ఏమైతుందంటే ఇక్కడ ఒక్క నిమిషం, ఇక్కడ చూడు, ఒక్క నిమిషం ఇదంతా ఎరేస్ చేస్తాను నీట్గా. సో వాట్ హ్యాపన్స్ ఇస్ దట్ whenever set timeout function gets executed, that function whatever we are passing in as an argument for that particular set timeout function will be registered and the timer will be started for that particular function. Okay, and whose timer will get completed first, that will be pushed into callback queue. Okay, you see, 1 second. You see, for example, I made this one as 6,000. Okay, and when the instruction at line number 16 gets executed, test1 will be registered. Test1 will be registered for how much time? 6 seconds. 6,000 milliseconds means 6 seconds only, right? And the timer will immediately, once after the registration is done, the timer will be started immediately for that. Okay, it won't wait for anything and the timer gets started for it. Okay, now immediately what happens after executing this instruction means registering test1 for about 6 seconds. Now once the registration is done, then immediately line number 17 will be executed. So in line number 17, test2, which is the function, will be registered, because since it is also a test set timeout function, test2 will be registered for how much time? 3 seconds, and this timer will also be started now. Okay, now before registering, between registering this one and this one, how much time lapse is there? Could you expect? 0.00001 milliseconds, something like this, because they both are side by side and it takes very less amount of time to register it, and after registering it immediately it will have to execute line number 17. That means that is also a registration, and the time gap between registration of these two will be very small. Okay, now whenever it registered, its timer got started, and whenever it is got registered, its timer is also got started. Okay, did you understand?
Yes sir.
Yes, right. And whose timer will get completed first?
3 seconds.
Yes, 3 seconds. So whoever timer gets completed first, that will be pushed into the callback queue. So test2 will be pushed into the callback queue, something like this. And then the global execution context, in the global execution context, it was already been removed. Okay, after executing this line number 18, immediately it got removed. That means after registering test2, we are done with the line number 17, and then immediately line number 18 will be executed. So this test2 will be now pushed into the callback, and test2 execution context is created and it will be executed. And after execution, what will happen? It will also be removed from the callback call stack, and then this is all, as it is been pushed from here to here, it will also be removed from here. Okay, and now after 3 more seconds, what will happen? Because it took only 3 milliseconds, 3 seconds, and after 3 more seconds, its timer also gets completed, right? Because these two are almost registered at a single point of time with a time gap of 0.001 milliseconds. So we can think like these two are registered almost at same point of time. Okay, now the stack is also empty. After 3 milliseconds, what will happen? Test1 will be pushed into the callback queue, and event loop is responsible to pull and push it into the call stack. So it will be removed from here, and test1 context will be created in the call stack as the stack was empty. Okay, and now it will get executed, and then it will also be popped out from after execution. It will also be popped out from the call stack. Clear?
Yes sir.
Understand?
Sir, understand. But I think పైన లైన్ అట్లా ఎంటీకి వచ్చేసి ముందుది రిఫ్లెక్ట్ అయ్యి తర్వాత అది రిఫ్లెక్ట్ అవుతుంది అని అనుకున్నాను.
లేదు అలా కాదు, వెరీ సింపుల్. ఇఫ్ యూ అండర్స్టాండ్ ద కాన్సెప్ట్, ఇఫ్ యూ అండర్స్టాండ్ ద కాన్సెప్ట్ ఆఫ్ registration of function somewhere, you imagine somewhere they are registered and the timer gets started whenever they get registered. Okay, so if you understand that concept, you can play with it for sure. Okay,
ఓకే
so now this is what the entire things on what call stack, callback queue. And can you tell me what happens if both timer gets completed immediately and the
Sir, the
if
execution
both of
will happen line by line. So first one will be execute first.
no, see, if
Stop.
both timers are getting completed at the same point of time, at same point of time cannot be done anything, right? So
Yes.
there might be a very small delay, right? So for example, test one's timer got completed and immediately test 2 timer also got completed. So in this
FIFO.
queue they both,
FIFO.
yeah,
first
yes,
came,
exactly,
first served.
yes. So they both will be pushed simultaneously with a very small time gap. So whoever came into this callback queue first, that will be served and pushed into the call stack, and whoever came next, that will be then pushed into callback. So that's why we name this as callback queue. Got it? Did you understand this, everyone?
Yes, sir, understand.
Pakka? See, if you understand this, then I can move forward.
Understood, sir.
Okay. Now what I'll try to do is that I made a simple point in between. I think you people might have forgot, but that's the important one. So what is the work of event loop? Can you define? At last minute, we'll stop the recording, okay? At last minute, and you'll create another meeting, okay? So what is the work of event loop? Anyone can unmute and tell me.
To
I told
to
fetch
fetch the instructions from the callback queue to call stack
not
when the
instruction, but
time
the
out is
context functions.
context.
Yeah. So to fetch, actually callback event loop is the one which monitors both call stack as well as callback queue simultaneously. And when call stack becomes empty, I'm stressing this point, when callback becomes empty, and in callback queue, if there is something that will be taken out by the event loop and kept inside the call stack. And once the function is being kept inside the call stack will be executed immediately. That function, whoever who is put inside that. Okay, so what I stressed here, when the call stack becomes empty, then only event loop will look or monitor the callback queue, and if there is something enters into the callback queue and simultaneously as call stack is empty, then that will be executed. Now what I wanted to do is that I want to wait my CPU here. So I'm going to create a for loop. So you create another meeting. I'm going to make it really interesting. Let us stop here and you create another meeting. Navin, because there is only 1 minute left, I guess. Hello, Navin.
Yes, sir.
Yeah, you create another meeting.
Okay,
as
sir.
we don't have much time.
Okay, sir.